To fully convert our interpreter to use continuations, then we need to consider all the other cases inside the interpreter that we haven't converted yet. So we dealt with numbers and plus. Multiplication is just the same, and that leaves functions and function calls. Functions are especially straightforward because, just like integers, we immediately get a value back. So in the new interpreter, we continue with the current continuation, giving it that value, and we don't need to change continue at all because there's nothing extra we need to do when we start evaluating a function expression. We just produce a closure right away. On the other hand, in the case of application, we used to have several steps. We would evaluate the function, then we would evaluate the argument, then we would actually perform the function call. So two separate steps similar to plus, but different kinds of step at the end. So now we're going to start interpreting the function expression, remembering that after that we need to interpret the argument expression and then actually perform the application. So I remember the argument expression and environment and whatever we're supposed to do with the result of the function call, which is represented by k. On the continue side, once we have gotten a value for the function, v is a value for the function, that is the result of evaluating the fn expression, then we start interpreting the argument expression in that environment that we remembered. Meanwhile, remembering that after we get a value for the argument, we need to actually apply the function. So we end up with a do app k as the next step, remembering the function value and then whatever we're supposed to do after we call the function. Finally, when we get to do app k, we remembered that function value from before. Now v represents our argument value. So as long as that function value is in fact a closure, then we can take the environment remembered in the closure, we can bind the name that's remembered by the closure to the value that was passed in as the result of evaluating the argument expression. That gives us the extended environment we can use to interpret the body. When we interpret the body, though, what do we have to do after that? It turns out there's nothing new to do. Whoever is waiting for the result of the function call can be said to be waiting for the result of the body expression. So we just use that same continuation that was remembered at the end of appk or appargk, which was the continuation originally passed in when we started applying the function. So one more time, the continuation for calling a function is also the continuation for interpreting the body of the called function. We can see how this plays out in an example. Let's suppose that we jump into the middle of an interpretation where I've already created this closure for the identity function. It takes x and returns x, and bound it to f in the environment. And let's suppose we're at the point where we're calling f on the argument 1. So this is our current expression to interpret f applied to 1 in an environment e1 that supplies a binding for f. And let's suppose that after we call the function, we don't have anything else to do. So the way this works is the app e case will start interpreting the function expression. That is, it'll start interpreting f in the current environment e1. We will remember that after we get a function, we need to interpret 1 and then actually perform the application, and then we'll be done. When we interpret the ID f, we haven't shown it on the slides, but of course you use lookup on the environment and you get a value back right away. So in this case, when we look at e1, we'll get the close v value. That's what we can pass in as the value to continue with the current environment. So just like int e and fun e, we get a value right away for an IDE, and we continue with the current environment. In this case, that value is a closure. When we continue with the apparg case here, so v represents the function that we got back from evaluating the function expression. We will remember that in a do app k, so we remember that closure in a do app k. Meanwhile, we start interpreting the argument expression 1 in the environment that we remembered for it. And of course, that is going to give us an int v right away that we continue with in our do app k continuation. So int v1 is now v in this do app k case. Vf is that closure that we remembered before. We match on it to pull out its pieces, and we see that we start interpreting the body here, which is IDEX. And in the extended environment where we bind the name x stored in the closure to the argument value in v1, that's the v here that was passed in to continue. So right here, x is bound to 1, extending the environment for the closure, which is empty environment. And then we have the rest of the continuation done k. When we interpret IDEX, we will find it in the environment. We will get an int v1 from the environment. We can continue with the done k, and that means we get 1 out at the end, which is what we expected, starting out with f applied to 1, where f is bound to the identity function.